Okay, latitudes are imaginary lines on the Earth's surface. It varies from 0 to 90. So as you can see, if you see the globe, these are the pole: north, south, east, and west. So the line that runs from 0 to 90 up and down are called the latitudes. So, and it varies from 0 to 90. Okay, the one in red is called the equator. That's latitude 0. So why others, they are not 0, so they could be 10, 20, 40. So as you increase towards the north or south, it increases to 90. So the maximum is 90. So from 0 to 90. So this could be maybe 30. Maybe this is 60. So that's it. Why again this could be 30, maybe 60. So it increases from the equator to north or south from 0 degrees. So this latitude is called latitude 0, is called the equator. Okay, let me write. So latitude 0 degrees is called the equator. So that's very important. So let's look at longitude. Longitude are imaginary vertical lines on the Earth's surface. It varies from 0 to 180. So as you can see, we have, as you can see, they are running from, like the former one, the latitude runs from equator to north or south, but this runs from the, we call it prime meridian, that's longitude 0. So let's use this red one. This is called the prime meridian. If you don't call it, you call it Greenwich meridian. Greenwich meridian. So that's longitude 0 degrees. So it's so we increase. Maybe if this is 0, this could be maybe 70. This is maybe 120 to what? Maybe 18. So this something, this maybe, if you take this as 0, so depending, 70, and this is maybe 150 to 180. So it runs from 0 to 180, west or east. Okay, let's move to location of points. So for us to locate any point on the Earth's surface, we need to know the latitude and the longitude. So the point of intersection of the latitude and longitude is the place we are looking for. So know that the intersection, to locate a point, we need the intersection of the latitude and the longitude of that place. So example, now if we are to locate, and mind you, we always locate a point, is always written latitude followed by longitude. So the easiest way to know is by so to locate a point, the first one is always the latitude, while the second coordinate, the first coordinate is the latitude, while the second one is the longitude. So as you can see, north, south, south. So whatever that you see here must be either north or south, while whatever you see here is either east or west. So let's now locate these points. So the first one, let me change color. Okay, let's use, the first point, they said 60 north, 60 west. So the latitude, remember, starts from 0 towards north, so 60. So if I can, let me take this as 60. So we've located 60 north, because it's either north or south. Down here is south. So why 60 west? So look at west. So let me take this as 60 west. So that's it. So this point, the point of intersection, this is our latitude 60. So this is my point. This is my point. So this is point A. The point of intersection of 60 north and 60 west. So that's it. So coming to B, 60 south. Okay, let me take this as 30, and let me take this as 60. So it must increase tonight. So I've located my 60 south. So remember, this is always up is north, down is south. Why 30 east? As okay, this is east. This is, so let me see. Let me look at this. Let me call this as. Let me call this 30 east. So what was the point of intersection of 60 south and 30 east? That's it. Do you see it? This is the longitude 30 east. Why this is the latitude 60? So this is point B. So as you can see, it's very simple to locate point. YC is 30 south and 30 east. So as you can see my 30 east, why this is my 30 south. So this is point C. So it's very easy for us to locate points. Once you know the longitude and latitude, the point of intersection becomes the place we are looking for. So let's now move to distance, calculating distance between 2 points along the longitude. So this is very, very important. For us to calculate the distance between 2 points, we need to know this, that the 2 points must have a common latitude or a common longitude. Yes. So for us to calculate the distance between 2 points, the 2 points must have either common latitude, if it's the distance along the latitude, or common longitude. So that's the first thing. So since we're on longitude, so they must have common longitude and different latitudes. So that's it. So we're on longitude. So assuming I want to calculate like this point, so assuming this is a longitude, I want to calculate distance along this longitude. So maybe if I call here A and call here B, so what do you notice? They must have common longitude and different latitudes. So if I call here maybe theta 1 of north, why here could be theta 2 of south. So that's it. And again, remember, this is a sphere, like a circle. So and as you can see, the distance between A and B is the arc of a circle. So we can get the radius, the circle, because this is like the center. So we need the radius. So if we join O to A and O to B, we have the radius of the circle. So the radius of the circle is r, big R, which is, remember, if you notice, they are all big circles, so they are all the same. But for latitude, I forgot to say that, you notice that the radius is only this equator, that the radius is the radius of the earth. So is the radius. Another thing we need to know is that we need to get this angle. Yes, because for us to calculate the length of arc, we need the central angle. And how do you do it? So if you take this as, we need to, common sense will tell us that since they are of different hemisphere, that's not our south, you see that the angle here is the addition of these two angles, theta 1 plus theta 2. Because if we take this as the latitude 0, so if you move up, is theta 1. That's, I'm saying that if you partition this first part is theta 1, while the second part is theta 2. So the total angle is theta 1 plus theta 2. And if you could remember our formula for length of arc is always angular difference. So I'm saying that from here, AB, which is the length of arc, is always angular difference which is that's latitude over 360 times 2 pi r, where r is the radius of the earth. So that's it. So if they're of this, it depends if they're of this same hemisphere. So assuming, okay, assuming I draw, okay, maybe let me use the equation to explain that. Okay, look at this question. We're asked to, okay, look at this. They say 2 points A and B are on the earth's surface. Calculate the distance between A and B to the nearest kilometer. So see my globe. So let's locate the point. They say 30 knots and 30 knots, 30 west. So see the west. So if I take this to be 30, let's take this to be 30, or maybe, okay, let's take this, the red one, to be 30 west. So this 30 west. So they said 30 knots. So if I take this to be 60 knots, because I have 60 and 30, so this 30 knots. So the first A, the point of intersection of 30 knots, that, so the first one is this. So this is my A. While my B is 60 knots, 30 west. So the same 6. So do you see it? They have common longitude. So the distance is along the longitude. And this is my center, as you can see. So if I join the radius, this is my radius. So the radius is r and r. So let's get the angle. So as you can see, the equator, the radius is 0. So if we start from 0, assuming, okay, let's take this to be the axis. So they said from here, from here to here is this 30 degrees. Have you seen it? So that's how we moved 30. So this is 30. Why from here to that same, from here to here is 30 degrees. This is 30. Why from here to here is 60. So since here is 30, so the remaining should be 30 to make it 6. So 30 plus 30 is 60. Do you see the logic? See what I mean? Let me draw it out. We have something like this. So from here to here is 30 degree. Why from here to here is 60. This is 60 degrees. So meaning that here is 30, here it should be 30 to make it. So 30 plus 30 is 60. This is A and this is B. So we are to find this. So using our formula for length of arc, we can easily see that AB is, the angle is 30. That's the difference. 60 minus 30, that's 30 degrees over 360 times 2 pi r. So we take pi as 3.14 maybe 2.8 times the radius of the earth r. We normally, the radius of the earth is always 6,400 kilometers. So we've used our formula 2 pi r. So we can calculate, this is, you can multiply, let me get my calculator. So if you multiply 30 times 2 times 3.1428 times 6,400 divided by 360. So the answer is 3,352.32. So this is 3,352.32 kilometers. So which is approximately 3,352 kilometers, because they say to the nearest kilometer. So you need to draw a clear diagram so that you can solve any question on that. Thank you. Okay, we're on distance between 2 points along the latitude. We've done longitude, and as you can see from the diagram, for us to find the distance, like assuming this, if you are given maybe this point A and point B, and we are asked to find the distance between these two. This is an arc of this circle. So if this is the center, so once we know this is the radius, this is small r, let's use small r, because the radius of the earth we normally use big R, which is 6,400 kilometers. So you see that, you notice that the radius we use for distance along the latitude is different from the radius we use, because they are not the same. It's only the equator that the radius is the same as the radius of the longitude. As you can see, if you connect here to here, is a big radius, which is r, because this is a big circle. So let's now find the relationship between small r and big R. So assuming we are given this, so if I join these points, I've joined So I've joined some points. So if we call this the radius of the Earth, that's the big radius for the R. So assuming from here, this is the center of this small circle. So if I call this the small radius, the radius of this small circle, so I want to relate small r and big R, but we need an angle. So assuming this is the latitude, remember we measure latitude from horizontal. So if I call this phi, so you can see that, remember this is 90 because this is a straight line, this is a triangle. So if you look at triangle, maybe let's call it triangle A, B and O, that's triangle OAB. If this is phi, this is also phi by alternate angle theorem. Do you remember alternate angle theorem? This is a transversal. So using our soccer tool from elementary trigonometry, that cos phi, cos is always adjacent over hypotenuse, so which implies that small r is always r cos phi, where phi is the common latitude. I told you for us to find the distance along the latitude, we must have common latitude, but if it's along the longitude, they must have common longitude. R is the radius of the Earth, while small r is the radius of the small circle, or maybe let's call radius of the latitude. Maybe let's write radius of the small circle. So each time we are to find, from what I just explained now, that if you are to find the distance between this A and B, since this is a circle, we know that the distance is always is a length of arc now. So angular difference, so depending the angular depending if they're on different hemisphere, even on the, as you can see, they're on different, so we add. So I will use the example times 2 pi small r. So we are not using the big R now because we are on this small circle, so we use small r. So let me use the equation to illustrate this. So they say 2 points, this and this, are on the Earth's surface. If it takes an airplane 10 hours to fly from A to B along the parallel of latitude, calculate its speed. Okay, we know that speed is always distance over time. So we need to get the distance first before we are given time. So once we know the distance, we found the speed. So let's draw the diagram. So look at my globe. So if I locate this is 30, so they say 30 north, 60 west. Why this is 30 north, 30 east. So they have common latitude of 30. So if we call here, let's call this 30, latitude 30 north. So why this is 60 west, why this is 30 east. So if I take this as my longitude 60 west, why this foot, let me take this as my longitude 30 east. So as you can see, both have common. So this is point A, while this is point B. So we want to get this length. So as you can see, this is the middle of this circle. So the radius we are going to use here is the small r, the same small r. So for us to get, remember, we measure latitude from, let me use a straight line so that, okay, we measure, okay, let me just draw. So see what we have here. This is my axis, this B, and this is A. So this is my small r. So let me use 0 subscript 1 to denote the center here. So the first one is 60. So here is 60 west, while this is 30 east. So my total angle is 90. So to calculate AB is very simple now. The angular difference is now 90 degrees. So 90 over 360 times 2 pi r. So times, let me use 22 over 7 times our r. Remember, I told you small r. Small r is big R cos phi, where phi is the common latitude. Well, I proved it here. So the radius of the earth is 6,000. Always remember that 6,400 cos phi is 30 degrees. So this is 1 over 4. So this is half. You get this 120 over, so this is half times 22 over 7 times 6,400. Cos 30 is, I think it's root 3 over 2. So we can see that this is 2 to 11. So 11 times that is, so I have 11 times 6,400 over 14 times root 3, times root 3. So let's find the product. We have 11 times 6,400 times root 3 divided by 14. So we have 8,709.7. So we have 8,709.74 kilometer. But remember, we are asked to find the speed, not the distance. Therefore, the speed is 8,709.74 over 10 hours over 10. So this is now 870.974 kilometer per hour. Or they say to the nearest kilometer per hour, so which is approximately 871 kilometer per hour, the nearest kilometer. So that's the answer. So please, whenever you're asked to solve this, just draw a clear diagram. You are good to go. So they said the ratio of the diameter of the earth to the distance between A and B is, well, as you can see from the picture, you see that A and B lies on the equator. And the equator is a great circle. So the radius of the equator is the same as the radius of the earth. So using our distance formula arc, we know that AB, the distance is the angular difference. As you can see, this is 60. The longitude of A is 60, while the longitude of B is 30. So since they are of different hemisphere, okay, let me just join. So this is 60, why this 630? So the angular difference, I have an arc, something like this. So I have something like this. This A and this B. The angle here is 60 plus 30, which is 90. So to find the length of arc AB is now 90 over 360 times 2 pi r. Yes, because the equator, the radius of the equator is the same as the radius of the earth. It's a big circle, and we're asked to find the ratio of the diameter, and you know this 1 over 4. The diameter, you know this is circumference, so we can write it as pi d. So pi d over 4. This is 1 over 4. 2 radius is diameter. So if you now find the ratio of the diameter to AB is now 4 over pi. Yes. AB is equals to pi d over 4. So d over AB is now 4 over pi. And we know that pi is 22 over 7, which is 4 times 7 over 22. So we have 14 over 11. So what we are looking for is 14 is to 11. So option B. So it's a very simple question. Thank you. Okay, they said we are given the diagram. We are asked the ratio of the circumference of the earth to the distance between C and D is dash. This is very simple question. Looks hard, but it's not hard. So just logic. CD and CC. So we are talking about distance along the small circle, and we know that the distance is always the angular difference. Angular difference you add or subtract depending if the longitude are on different hemisphere. As you can see, this is 60, this is on 60, longitude 60, while C is on longitude 30. So they are different. This is west and this is east. So we add. So we have 60 plus 30 over 360 degrees times 2 pi. Remember, this is small circle, and I've done the relationship between the small circle and the radius of the earth. It's always the radius of the earth cos the common latitude. As you can see, they lie on 60 degrees, so 60. So what we have here is 90 over 360, which is 1 over 4, and cos 60 is half. So I have 1 over 4 times 2 pi r is the circumference of a circle times half, because 60 is half, CD. So we're asked to find the ratio of the circumference of the earth. So which implies that the ratio circumference of the earth over CD, the distance between CD, is now 4 times 2 is 8, 8 over 1. Yes, because this is like circumference over 8. 4 times 2 is 8. So the answer is 8 is to 1. So it's a logical question, very simple. Option D. Thank you. Okay, look at this. We asked if A with latitude phi and theta 1, longitude theta 1, and B, latitude phi and theta 2. Then we're asked to find the distance between A and B. So before now, in our introductory video, I said that for us to find the distance between 2 points on the Earth's surface, they must have either common latitude or common longitude. And if they have common latitude, means that the distance is along the latitude. While if they have the common longitude, the distance is along the longitude. So looking at this question, they have common latitude, so the distance must be along the latitude. And we know that the distance is always the angular difference. Since the distance is along the latitude, the angular difference will be either addition or subtraction of the longitudes times 2 pi r, and the r we are going to use is small r, and we know that small r is always r cos common latitude, which is phi. So what's our angular difference? This is west and this is also west, so the two must, one is bigger than the other, one must subtract. So I'm looking at the option, this is off because they are not in different hemisphere. This is west, this is off. So let's try this. So we here now we assume that theta 1 is greater than theta 2. Yes, based on our assumption. Let's solve before we know whether it's A or D. So this is off, times 2 pi r, and what's the common latitude? Phi. Okay, cos phi. So as you can see, this is theta 1 minus theta 2. 2 in that, so we have over 180, and in trigonometry this is times pi r. Cos is the reciprocal of sec, and sec is the reciprocal of so meaning that we can write cos as 1 over sec. If you could remember your trigonometry, so the answer is option A. So the best option is A. This could have fit in, but this is plus because this is also cos phi, because sin 90 minus phi is from our trig complementary identities. Cos theta is the same as sin 90 minus theta, so it's not, but due to the addition, so it's off, so it's only the first option. Option A is a very nice question. Okay, we are asked to find distance AB if you are given points A and B. Okay, this is a very straightforward question. As you can see, the latitudes are different, so this is distance along the great circle because they have common longitudes. So we know that distance is angular difference over 360 times 2 pi big R, where R is the radius of the Earth. Angular difference is now the latitude, that's the angular difference, the latitude difference. So, and if you notice, both of them are in the same hemisphere, not north. So if they are the same, you subtract. If they are different, you add, because they are in the, okay, example, if this is my axis, so this is my center of this globe. So if this is the common longitude, this is the common longitude, while the latitude, maybe this is the first, this is the equator, maybe this is the latitude, the first latitude, and this is the second latitude. You see that if they are in different hemisphere, you add the angle, but if they're in the same, you subtract. So we have, so this is off, this is off. So here we assume that phi 2 is greater, sorry, phi 1 over 360 times 2 pi r. So this is 2 that, so we have phi, sorry, I always write it, phi 2 minus phi 1 over 180 pi r. So the answer is D, none, because this is cos phi. It's not distance along the latitude, is along the longitude. So it's just a simple question. Thank you. Okay, they said a helicopter flies from A with latitude and longitude 60 north and 60 west. Why this B 60 north 20 west? If the journey takes 120 minutes, calculate to three significant figures the speed of the helicopter. The second part of the query, if it then flies due north from B to C 640 kilometers away, calculate the latitude of C. Okay, look at this diagram. So this is my globe. So let me now label the latitude and longitudes. So 60 north. So let me call here, okay, let me call here 60 north and 60 west. Okay, let me call here 60 west. So why here? So my point, the point of intersection of 60 west and 60 north is this. So this is my A. Why this is 60 north 20 west? So let me take this as 20, because 20 is less than 60. So this is my 20. This is my 20 west. So my aim is to find the speed. We know that speed is distance over time. Distance over time. And we are to find it. So if you take, because this is distance along latitude, so if this is the center, let's call it O subscript 1 with radius, this is small circle. So small circle, the radius is R, the same small r. So we have something like this. We have something like this with the axis here, this over. So this is B and this is A. So we'll see that B, the latitude of the longitude of B is 20. So this is 20. That's it, 20. Why that of A is 60. So meaning 20 plus 40 is 60. So let's calculate AB. Let me draw a line. So using our length of arc formula, AB is theta, which is 40 over 360 times 2 pi r. So let me use pi 22 over 7, and r is always big. I've derived it, so big R, and we know that is 6,400 cos the common latitude, which is 60, because I have common latitude 60. So this is 1 over 9 times, okay, this is half, because 60 is half, so half, so I have 22 times 22 over 7 times 6,400, because 60 is half, so half. So let's use calculator so that we'll get it fast. Let's find this. So I have 22 times 6,400 divided by so I have 22, I have 2,200 and 2,234.92. So this is our distance, kilometer, but they ask us to find the speed. So speed is always distance, speed is distance over time. So this kilometer, they say kilometer per hour, because they gave us 120 minutes means 2 hours. So I have divided by 2, so 2234.9 divided by 2. So I have 1117.45. So that's our speed, kilometer per hour. So they say to the nearest, to 3 significant, 1 to 3. So I have 0.2 1120 kilometer per hour to 3 significant figure. So the next question, they said if it then flies due north to sea, which is 640 kilometers away. Okay, look at the diagram. So they said if it now flies to sea, so let's C be, they ask us to find the latitude of, so let the latitude of C be, maybe let's use file. So if C, this is point C, yes, it flies due north to point C, so from B it goes up to C, so it must be along the longitude because you can't move on the empty space. So we're asked to find the latitude of C. Common sense will now tell us that we are now on distance along the longitude. Yes. So see what I have here. So CB and CC. So our distance along the longitude must be, is a great circle. So C will connect it. This is now big radius R. Big radius R. So no more this, because this is the distance along this big circle. So I have so this is now distance along the longitude. So big R, big R. So they say the distance is 640. So we want to get, as you can see, this is B. We know that longitude, the latitude of B is 60. See where the mathematics comes in. The latitude of this is 60. We want to get the latitude of C, so which is file. So the middle here will now be file. The middle here, the angle between these two is now 5 minus 60 degrees. Do you get? This is 60. Why the total here is 5. So the angle between B and C is now 5 minus 60. So the latitude of C must be greater than B. Yes. So we now, they gave us that the distance between B and C, which is 640, is now equal to the angular difference, which is 5 minus 60 over 360 times 2 pi big R. So 2 pi is 22 over 7. Big R is 6,400. So let's make phi the subject of formula. Phi is now 60 plus, you get this in this, remaining 10 here, 0 0, remaining 36, 2 in 36, 18, 2 in 22, 11, 18, 9. So 9 times 7 is 63 over 11. So this should be 63, and that this should be 55 plus 8 times 9. So I think this is 65 point something, because 63 over 11 is point. So this is 5.7, so 65.72 degrees. So that's the latitude of C. So it's a tricky question, very simple, but it's very tricky. Thank you. Okay, welcome to the last part of longitude and latitude. That's the subtopic is shortest distance between 2 points on the Earth's surface. What if I tell you that the shortest distance between 2 points on the Earth's surface is the distance along the Great Circle? So I'm saying that the shortest distance between 2 points on the Earth's surface is the distance along the Great Circle. That's distance along the longitude. And you might ask a question, why are we now talking about the shortest distance? Or you might be confused. You say, you assume that we've done distance along the longitude. Yes, this part is very important, because here in most questions you might be given a common latitude, which is now the distance along the latitude, and you might be asked to find the shortest distance between the 2 points. That's, you are given 2 points along the same latitude and different longitudes, and you are now asked to find the shortest distance between the two. I'm here to tell you that the shortest distance is the distance along the longitudes, and I'm going to prove it now. So assuming you have this diagram, we are given 2 points. Assuming you are given that you are given 2 points with latitude 60 and longitude 20, and latitude 60 and longitude 30, and we're asked to find the shortest distance between E and C. I'm here to tell you that the shortest distance is the distance along this longitude. Yes, instead of latitude. I'm going to prove it. So I'll derive a formula for that, and we solve questions. That's, I will solve the normal distance along the latitude. We now compare the distance that we'll get along the longitude to know which one is shorter. So this is the diagram, because for us to find the distance along the longitude, we need to connect the radius of the Earth. That's the radius of longitude, which is the big circle. That's it. So that's, you see the center of this, of the globe. This is the radius from E. This is E to C. So why the center here is this O subscript 1, why the radius of the small circle is R, that's the R. So as you can see the axis, and maybe this is the North Pole here. So we just copied here this from here so that you can picture what is happening. So as you can see, we know that the common latitude here is 60. So let's take the common latitude here, assuming this is a complete. The common latitude, let's take it to be 5. That's, in this case, is 60. And we know that when we are to find the distance between these two, the angle here is 20, while here is 30. So if we take the total angle, here is now 20 plus 30. So let's take the total angle to be theta. So connecting this perpendicular, divide this into theta over 2, y theta over 2. Theta is our angular difference. Theta is our angular difference, and the same thing, this bisect this angle. Let's call this beta. Here is now beta over 2. Beta over 2. Because we want to get the distance now along this path. So we're going to use this angle instead of this. But we're going to use this to get this. So do you get the logic? I'm saying that we are formally, you'll be given the longitudes, the angular difference here in terms of longitude, but the actual angle, because we are to find the distance now along this, we're not going to use this. What we are going to use is this angle, and this line, our axis, bisect it into 2. So our main aim is to find the angular difference here now, which is beta. So we'll start. You notice that if we connect E to C, we have a chord, because this is an arc. So if you connect E to C, we have a chord, and we know that a chord, okay. So I'm saying that in triangle OEC, that's O subscript EC, OEC, the chord, which is EC, is, remember the formula for chord, length of chord is 2r sine theta over 2. You get the logic. The chord, if you could remember, in our circle geometry, the length of chord, so this length in terms of this triangle OE, that's O subscript 1 EC, this length of chord is 2r small r sine half theta. And we know that small r in terms of big R is 2r cos phi, where phi is the common latitude, sine theta over 2. So that's the first thing. If we come to the other triangle, that's triangle, the bigger one, triangle OEC, we can still get the length of chord because it's a chord. So see our arc here now. So the chord EC. So in triangle OEC, we know that EC again is now 2r sine beta over 2. So you can see, if you could remember from our basic circle geometry. So let's now connect the two. EC is this, and that same, okay, let's call this equation 1, this equation 2. So what do you observe? You notice that 2r cos phi sine theta over 2 will be equal to, okay, let me just remove this, will be equal to 2r sine beta over 2. So our main aim is to find beta, because we are not giving beta, we are giving theta. From this, theta is just the angular difference here, which is in this case is 20 plus 30, but we use theta to represent that. And since this is a perpendicular bisector, so it bisects the angle. So let's find beta. So 2r. So I have cos phi sine theta over 2 equals to sine beta over 2. So we divided both sides by 2r. So making beta the subject of formula, remember this is beta over 2. So this is beta over 2 arc sine of, or sine inverse of, cos phi sine theta over 2. Which implies that making beta the subject of formula now, beta is now 2 sine in arc sine of cos phi sine theta over 2. So this is now our angular difference. Therefore, the distance now along the, we've gotten this angle now, so we'll find our normal distance, which is the distance along this longitude, this length of arc. Therefore, the distance along the longitude, which is the shortest distance. Therefore, the shortest distance between 2 points on the Earth's surface is now equal to beta. Remember, beta over what? Over 360 times 2 pi big R. But beta, we've derived that beta in terms of file and to 2 arc sine of cos phi sine theta over 2 over 360 times 2 pi r. So we can still simplify down to, so we can now simplify, so that's the distance, the shortest distance is now, I said, is 2 arc sine of cos phi sine theta over 2 over 360 times 2 pi r. So we can reduce 2, so 2 times 2 is 4, so 4 in that is 90. So I have arc sine of cos phi sine theta over 2 pi r over 90 degrees. So this is the shortest distance between 2 points on the Earth's surface. We'll prove that by solving, I will solve this question using the normal distance along the latitude, and after we now use this formula. Okay, remember where we didn't describe the form, where phi is the common latitude and theta is the angular difference, as the angular difference between the longitude. So let's solve. So let me copy the equation. So we want to solve this now. We want to find the distance between E and C in terms of latitude, distance along the latitude, and after we now solve along the longitude to know the distance, which one is shorter. So we know that the distance EC along the along the latitude, we've known that this. So if we connect, okay, let me just connect so that if we connect, this is the center. If we connect this is small r, this small r, our angle here is 20, while the angle here is 30. So our angular difference is 20 plus 30. So you have 20 plus 30 degrees over 360 times 2 pi 22 over 7 times small r, and we know that small r is big R, which is 6400, cos phi is 60 degrees. So we have 50 over 36, which is 5 over 36, times 2 times 22 over 7 times 6400 times half. I think something, this gone, this gone. So we have 2 here, so we have 5 times 2 here is 11 times 6400 over 2 here is 18, so 18 times 7. Do you get? This is off. 2 here 11, that's the 11. 2 here is 18, that's 18. So let's calculate those. This times 11 times 6400 divided by 18 times 7. So we have 793.65 kilometer. So that's the distance in terms of the latitude. That's along the latitude. So let's find, because our main idea is to show that the distance along this longitude is the shortest distance. So using this formula now, so let's substitute. As you can see from the equation, EC arc sine of cos 60 degrees, because that's the common latitude, sine our theta. Remember, theta is the angular difference, which is 20 plus 30 over 2. So times pi, which is 22 over 7, times 6400 over 90. So let's calculate. Cos 60 is half. Okay, maybe let's, we continue. Let's, this is arc sine of half, that is 50 25, so I have sine 25 over 2, because cos 60 is half. So this 50 over 2 25, so sine 25 over 2 times 22 times 6400 over 90 times 7. Okay, so let's solve. So I have shift sine bracket sine 25 over 2, that's 25 divided by 2, so whatever that I get, times 22 times 6400 is equal to this divided by 90 times that, which is 630. So I have 2726.39, 2726.398. So let's compare the two distances. So I say that the shortest distance now is 2726.398. So let's check the previous one. The previous one was 2793. Okay, let me just approximate so that you can easily. This is approximately 2794 to the nearest kilometer. So why this is 2726 kilometer. So what do you know? I think this is smaller than the previous one. The previous one is 2794, but this shortest one is 2726. So I've proved that the shortest distance is this. So question will come like that. They will give you the distance along the latitude, but they will ask you to find the shortest distance. So you have to use this formula. You have to use this. So I've proved it's a very important formula. But thank you.
We are asked 2 points A and B is on the equator, have longitude 162 and 74. That's degree east and 74 degree west. We are asked to find the shortest distance between them. So from our formula, the shortest distance between 2 points on the Earth's surface, as the distance shortest, is always 2 arcsine of cos phi sine half theta over 360 times 2 pi r, where phi is the common latitude, theta is the longitudinal difference, and r is the radius of the Earth, which is 6,004. Okay, they give us. That's the radius of the Earth. So now let's substitute. Okay, let's just reduce. We can reduce. 2 times 2 is 4. 4 in 360 is 90. So we have arcsine of cos, the common latitude, since they gave us the equator, the latitude for equator is 0, and the longitudinal differences, they are of different hemisphere, we add, but if they're on the same, we subtract. So times pi is 22/7, yr is 6,400 over 90. Since we've done 2 times 2, 4 in 36 is 9. So we can still reduce further. So we have 0 and 6/4. So we have, cos 0 is 1, so I have arcsine of sine. This, if you divide that, 162/74, 236/2 is 118. So sine 118 times, okay, we now have times 22 times 640 over 63. Yes, 9 times 7 is 63. So I think the answer is 13856.507 some, so 751. That's option C. So the idea is this formula, the shortest distance between 2 points on the Earth's surface. Thank you.